Dear learners, today we will be discussing about impact assessment methodologies. We will be discussing about the overlay techniques and networks. We all know that impact prediction, impact identification, it's a very essential part of environmental impact assessment process, because that indeed provide us a path wherein whether to go for a development project or not. So, environmental impact assessment, the process, the most important step in that process is the impact identification or prediction or monitoring. So, in that regard, the methodologies are many are there, and today's session we will be discussing about the overlay technique and the network. And if you look at the overlay technique, basically it is a it has been used in environmental planning and environmental management for a quite longer period of time. So this technique is very easy to use also and also understand. It's very, that's the reason why it's very quite popular in geographical studies or GIA study, and now in environmental impact assessment as well. So this technique is highly suited for EIA study. That involves the spatial features, spatial aspects. So in that regard, the overlay maps is doing a splendid work, or in other words it is having a lot of potential to enable the exercise of environmental impact assessment much easier and very productive. So in that way these overlay maps are very, very important. When you look at the these overlay techniques are excellent way of showing the spatial distribution of impacts. The impacts, we all know that impacts are it's short term, long term, it is reversible, irreversible. A lot of impacts are there, socio-economic impacts and physical impacts. So these all impacts can be visually presented by using a overlay technique. And this overlay map also lead intrinsically to a low impact decision making also. So in that way this is a significant improvement in over all other previously discussed impact assessment methodologies. The overlay maps, that method, is particularly useful for identifying optimum corridors for development, such as electricity, the lines or roads, for comparisons between alternatives, and for assessing large regional development projects. So in that way it is having a lot of applications. And when you look at this particular method, basically a series of overlaid map transparencies can be used to help identify, predict and communicate the intensity and geographical extent of impacts. What I want to say is that these transparencies, the transparencies are overlaid one above the other, and that way we are in a position to find out or identify, predict and communicate the impacts, both the magnitude, intensity and also the extent of the impact. So in that way we can understand that what is the significance of overlaid map. And when you look at the area, study area for that matter, what we will be trying to do is that the study area is divided into appropriate spatial units, small units, and information on a number of attributes such as the environmental factors, the human activities, all will be collected and it will be definitely incorporated in the particular transparencies or the layers. Because now we are using a lot of computer softwares and algorithms, definitely we will go for the layering that we will be discussing later on, but traditionally we will be using the transparencies. The transparencies, in fact, the transparency showing the showing the proposed development, the geographical extent of each attribute and each potential impact are overlaid one above the other. So when you place one above the other, that is called basically it's overlaying, you will be finding a kind of a spatial interaction that will be it's significant enough, and that can be assessed also. There are a lot of interaction that will be there in the spatial interaction between layer one above the other. The transparencies are produced, whatever the transparency we are talking about, it has been produced showing the spatial distribution and intensity of the individual impacts. And this is when you place one above the other, but definitely what will happen, ultimately you will be getting a cumulative impact or a total impact you will be getting it. So let us see one by one the steps. First step is that as far as the overlaid mapping is concerned, you will be preparing a base map, that base map showing the general area within which the project has to be located. That is the first step. Thereafter, successive transparent overlay maps are then prepared for the environmental components that in the opinion of the experts are likely to be affected by the project. It can be in the agriculture sector or the pollution sector. When you talk about the pollution, air pollution sector or the water pollution or even the noise pollution as well. So every the variables, the attributes, everything will be taken into account and will be preparing a kind of a map, overlay map. And thereafter the next step will be that the project degree of impact on the environmental feature is shown by the intensity of shading, the darker shading representing a greater impact, and that is how that we will be getting to know the final output. And when you look at the composite impact of a project, when you talk about the composite means I am talking about the cumulative impact. It has been found by superimposing the overlay maps one above the other. It has been superimposed, and finally what we will be getting, you will be getting the the final map, the composite map that will be showing the relative intensity of the total shading. And in the case certain areas are not shaded, it shows that the development project does not have any significant effect on that particular region. So the overlay map provides us a kind of study the impacts in a probably the most probable manner, in fact the best manner. Alternatively, the same process what you talk about the overlay can be carried out using GIS, the GIS, geographical information system. When you use that thing, definitely more number of transparencies or more number of maps can be laid one above the other, because there is no limitation. The limitation means I want to say is that because the computer algorithms are there which is more sophisticated, and it can help us to find out do the all spatial analysis even at the granular level. And in case of GIS, you can assign certain importance weightings also to the impacts, and this enables a sensitivity analysis to be carried out to see whether a changing assumptions about the impact importance would alter the decision or not. So this is a very important development. Of course, that's basically because of the software, that is the GIS software involved in that thing. That is the reason why it was very helpful to do further spatial analysis and spatial modeling as well, because that will be very helpful, because when you talk about the environmental impact assessment, the final stage comes at, after the prediction, the mitigation and also the monitoring aspect. So in that case, GIS will be very, very helpful. Nevertheless, there is a lot of practical limitations also to this particular technique, that basically it's a number of maps that can be used as the method, because when you increase the number of maps or number of layers, it becomes more difficult to analyze, and perhaps not more than 10 transparencies are used. Basically more, if it is increasing, definitely it will be difficult, and if you wanted to increase more, definitely the computers can be very, very helpful. And a lot of techniques also is there, for example the photographic and hierarchical clustering approaches also overcome this particular practical constraint. In fact, the usage is concerned, application is concerned, basically if you see these overlay maps have been used extensively for route selection, because basically in that case of route selection, these overlay maps have been used, and computers have enabled definitely in choosing the best possible route by taking into account a large number of environmental factors, or also that can incorporate the numerical analysis also into the site selection. So many factors can be incorporated into one graphic display, and a preferred route selection can be selected by choosing those grid cells possessing preferred combination of environmental factors. So this is about the overlay maps. It's a lot of advantages are there. Nevertheless, it has been used mostly for the route selection aspect, because of course with the advent of the computers and the GIS software, definitely if you look at it, more number of layers, more number of impact layers can be placed one above the other, and it has been helpful for getting better precision or better accuracy in spatial analysis. Certain limitations are also there with this particular methodology. The method is limited in that it does not consider factors such as likelihood of an impact. So that is one limitation, and also the secondary impacts or the difference between reversible and irreversible impacts, these all not been factored into this particular method. And very important thing, because when you talk about the GIS, you are superimposing one above the other. So in that case, it's the clear demarcation between the boundaries, it's difficult. Okay. So in that sense, it's definitely the accuracy and everything will be, constrained. It will be challenged. So what I want to say is that the particular methodology, it requires a clear classification, a clear classification of often indeterminate boundaries. Like for example, you have the forest and an agricultural land, the boundaries are very indeterminate. It's like the transitional kind of thing. So in that case, it's very difficult to use this kind of methodologies. But nevertheless, it is having a lot of uses as far as the EIA study is concerned. Next is next methodology is the flowcharts and networks. These are also very important methodologies as far as EIA is concerned, and these flowcharts and networks can be useful for identifying cause-effect links or pathways. Definitely it can use for identifying even the impact sources also, and sources and impacts, the relationship, the cause and effect relationship, and also between the primary and secondary impacts, what is the relationship, and these all the networks can be very well used. However, these networks or flowcharts cannot quantify the magnitude of the impacts or their effects. So that is a limitation of the flowcharts and networks. Nevertheless, it is having a lot of significance as far as environmental impact assessment technologies are concerned. So let us see one by one. First one is the network methods. When you talk about network methods, it emphasizes that the network methods emphasizes that the environmental systems, whatever we are talking about, environmental systems consist of complex web of relationships, and these network methods endeavors to reproduce that web. So the environmental system, what we are talking about, is a kind of a relationship. It's a complex web of relationships, and this network exactly reproduces that particular web. And in a way, we are syncing the process. We are moving towards the what is exactly happening in the environment. So in that way, this network method is significant. As far as the impact identification is concerned, using the networks, it involves basically because the effects of development through the changes in the environmental parameters in the models can be very well identified. Impact identification is much easier because in each and every step, what all been taken, what all the things happened, impacts, and everything will be taken into account as far as the network is concerned. Okay, networks represent an attempt to solve the problem of identifying second and higher order, tertiary order impacts. So in that, for example, the best one example is that Sorensen has given this particular thing, and the Sorensen's network development actions are linked to a series of changes in the environmental parameters. Okay, the Sorensen's network, that's a basic one, it's a famous one, was the first network method to be developed. It aimed to help the planners, the environmental planners, reconcile the conflicting land uses, particularly that in California, that particular model was used, the Sorensen network was used, wherein there are 6 important environmental components that have been taken into account. What is one of them? The other is the climate, geographical condition, biota, access condition, aesthetics. These are other parameters. Basically, the Sorensen method, started by the methodology started by identifying the potential causes of the environmental change associated with the proposed development action using a matrix format that we have discussed in the last session. For example, forest related activity. The forest related activity can result in the clearing of vegetation, and these environmental changes, clearing of vegetation, can result in what? Specific environmental impacts. Okay, for example, the clearing of vegetation could result in an increased flow of fresh water, which in turn could imperil the coastal environment, coastal ecosystems. So each and everything has been captured through this particular network method. Okay. As far as the analyst is concerned, because he is driven by certain objectives, the analyst, EIA analyst, what he does, he stops following the network when an initial cause of change has been traced through all subsequent impacts, okay, and changes in the environmental condition to its final impacts. Okay. So the environmental impacts can result either directly from a development action or indirectly through induced changes in the environmental conditions. So that so the impact is not only the direct, it can be indirect also, it can be secondary also, it can be tertiary as well. So a change in the environmental condition may result in several types of impacts, Essentially, this method, network method, should lead to the identification of remedial measures and monitoring schemes also. Basically, this is what the purpose of this method, network method. Definitely, it is aiming to fulfill these particular aims. Okay. In fact, as far as the positives are concerned, this indirect impacts are identified through this method, but there is no indication of relative importance. That is one of the limitations of this particular network method. With the increasing detail when analysis, however, networks become more cumbersome, and it's more complex, and definitely there's need for computers. That's because it's more and more, if you make it then it will become very complex to understand and to study the process. I'm talking about the environmental impact assessment process. So the approach here, the network approach, is useful for assessing single projects, single projects with the limited number of impacts. Single projects with a limited number of impacts. It could also be used to assess alternative strategies in plan formulation, but nevertheless the complexity would increase. That we need to take into account. So in a nutshell, this particular the approach can be used for a single project with a limited number of impacts. But of course, networks are easy to follow, and are very, very good for communicating impacts to non-experts. So that is a significant aspect of the network method is concerned. A simpler version of this particular technique is used in the development of transport plans. Normally it is extensively used in creating or constructing a transport plan. The best one is the causal chain analysis. It's basically, in other words, it's called as cause-effect diagrams. They are basically drawn by the planners to identify how one action, for example, it's a maintenance action or a renewable or a kind of a improvement in the transport sector, the system, and what kind of the change, one action, it can lead to what kind of changes in the social, economic and environmental conditions. So that also will be captured using this particular method. And also this the technique, the causal chain analysis technique, also identify what preconditions are required, what kind of preconditions are required to achieve a positive outcome, and so that the problems can be definitely avoided. And the limitation as far as the network methods are concerned, there are certain limitations are there. They require considerable knowledge of the environment. The network method requires considerable knowledge of the environment. And network methods do not establish the magnitude or significance of interrelationships between the environmental components or the extent of change. Nevertheless, the main advantage of this particular method is that their ability to trace the higher order impacts. I just talked about this higher order impacts of any proposed developmental action. Let us now discuss about the causal networks in environmental impact assessment predictions. An important element in prediction is the cause and effect relationship. Basically, cause and effect is a very important thing that we need to take into account. But such relationships, if you look at it, has been poorly understood. Definitely in EIA process also, a lot of things has to be done, a lot of study has to be required to understand and how best we can use this kind of network, that is cause and effect network, in our studies on EIA. Okay. So the causal network diagrams, that they demonstrate the relationship between the elements, elements of the environmental project also, and also different the environment also, the project and the environment. Okay. The special identifiers of causal networks are diagrammatic representation of relationship among the elements, that is what I talked about, elements, and the attribution of causality to those relationships. These are the basic things. So we know that the networks are basically abstract diagrams with the nodes and links. Okay. Both the network logic and causality logic of causal networks seem to sync well with the EIA process. There are two logics, one is the network logic, the other one is the causality logic. And of course, there are certain assumptions are there as far as this analysis is concerned. They do assume that there are links between individual elements of the environment and also project. I am talking about the network logic. The second one is that the causality logic. So when one element is specifically affected, this will have an effect on those elements that interact with it. That is called causality logic. So there are two logics are there. One is network logic and the other one is causality logic. Okay. A key strength of this causal network is their capability to follow impacts to several levels, because at each and every level it can go through sequence of interactions, and this may be the reason why these are also called as sequence diagrams. The examples of causal networks are digraph or a directed graphs. Okay, the digraph is the simplest form of the causal network. The elements are nodes and the directional links, because they are the basic elements of this digraph. And basically the directional links, I am talking about the unidirectional arrows with optional additional information marked directly on those elements. The plus or sign or a minus symbols can be used, showing the positive change or a negative change. Okay. And as far as the cause and effect flow diagrams are concerned, they are directed graphs, but their elements are stated only textually in various shapes, maybe a rectangle or a square. So they are less rich in information than the simple diagrams. Okay. So the cause and effect flow diagrams are mainly used in EIA for the identification and prediction of impacts related to development projects. Nevertheless, there are a few drawbacks with this particular methodology. There are difficulty to deal with the time aspect and the space aspect. The next one is the potential risk of increased complexity. So these are the two drawbacks as far as this particular methodologies are concerned. Thank you.